Good day and welcome back. In this video, we're going to talk about momentum. We will learn about principle of conservation of momentum, impulse, and also the types of collision. First of all, momentum is the product of mass and velocity of the object. Principle of conservation of momentum states that total momentum is conserved in a closed system where there is no external force. This is consistent with the Newton's first law of motion, that the object will maintain its state of motion, either stationary, which has zero momentum, or in constant velocity. Based on Newton's second law, we learned that the rate of change of momentum is proportional to the force applied. If we are in a closed system, there will be no external force to change the momentum of the object, hence, total momentum must be conserved in a closed system. For object in a constant velocity, so what happens if it collides with another object? The velocity of both objects will change after the collision due to the impulsive force exerted from each other during the collision. This is according to the Newton's third law of motion that every action has a reaction force. When the object collides with second object, it exerts impulsive force on that object, which can be formulated as the rate of change of momentum. It also experiences a reaction force which has the same magnitude but in opposite direction. We apply the Newton's third law formula that F is equal to negative reaction force, where the negative indicates that both are in the opposite direction. Substitute in the formula of force and rearrange it, we can obtain the equations of N1U1 plus M2U2 equal to N1V1 plus M2V2, where the U is the initial velocity and V is the final velocity. From here, we can see that the total initial momentum is equal to total final momentum of both objects, which we can conclude that total momentum is conserved. Next, we're going to discuss about impulse, which is defined as change in momentum. From Newton's second law, we can obtain the integral of F with time is the change in momentum. If we have the graph of force against the time, area under the graph is the total change of momentum. Let's see one example from trial paper of SMK King George in 2020. A particle of 5 kg undergoes action by a force which changes its momentum. From the diagram, area under the graph is representing the impulse or change in momentum. So calculating the area under the graph, we can obtain the total change in momentum is 50 Newton second. And then divide by the mass of object, we can obtain the final velocity of object is 10 meters per second, where the initial velocity is assumed 0 in this case. Next, we are going to look at elastic and non-elastic collision, which you should have learned it before in SPM. Here we just quickly do a recap. Similarity between elastic and inelastic collision is that total momentum and total energy is conserved in a closed system. The parameter that differentiates both these collisions is the final velocity of objects after the collision and the total kinetic energy in the system. For elastic collision, velocity of both objects will be different, and we have the equation derived just now. Total kinetic energy will be conserved in this case. For inelastic collision, both objects will stick together and move in the same velocity. We can simplify the previous equation to be N1U1 plus M2U2 equal to the product of total mass and the velocity. So please take note for this case, total kinetic energy is not conserved, but total energy in the system is still conserved. Part of the kinetic energy will be converted into another form such as heat, sound, and etc. Let's see another example from trial paper of Johor in 2021. There's a trolley X of mass 2.5 kg traveling at 0.5 meter per second and another trolley Y of mass 1.5 kg traveling at 0.3 meter per second in the opposite direction. Both of them will collide into each other. Now, let's discuss the first case if elastic collision occurs. We have total momentum conserved, so we can apply the formula and put in the values. Take note the value of the initial velocity, which is 0.5 meter per second and negative 0.3 meter per second, since they are traveling in the opposite direction. So we'll obtain the equations of 2.5v1 plus 1.5v2 equal to 0.8. Now, we have two unknowns, so we need another equation to find out their final velocities. The option we have is the principle of conservation of energy, that total kinetic energy is conserved in the elastic collision. Apply the formula of half mv squared, where the total initial kinetic energy of both objects is equal to their total final kinetic energy. So put in the value and simplify the equations. You will get the equations of 2.5v1 squared plus 1.5v2 squared equal to 0.76. The next thing is to perform simultaneous, and you should be able to obtain the velocity of negative 0.1 meter per second and 0.7 meter per second for trolley X and Y respectively. Now, let's talk about the second case, inelastic collision. Here, we just apply the formula mentioned just now, and we can directly obtain the final velocity of both objects is 0.2 meter per second. We also can investigate about their kinetic energy. Initially, total kinetic energy in the system is equal to 0.38 joule, and then after the collision, put in the value of final velocity of 10, the total kinetic energy now is only 0.08 joule, which indicates that there is 0.3 joule of kinetic energy is lost. According to conservation of energy, energy can be neither created nor destroyed, so it must have been converted into another form. So this is the inelastic collision. So that's conclude my discussion today. If you have any questions, leave it in the comment section below. Also, do leave a like and subscribe to my channel. I will see you in my next video. Thank you.